Today we've been asked to simplify the rational expression x minus 3 over x squared minus 25 minus x plus 2 over x squared plus 9x plus 20. The first thing we always want to do when we have a rational expression like this is factor any polynomials that can be factored. So this is really an exercise in factoring. So obviously the numerator cannot be factored. The denominator is x squared minus 25, which is a difference of squares. And that's going to factor to x plus 5 times x minus 5. Okay? Minus, again over here, x plus 2 doesn't factor. X squared plus 9x plus 20 factors into x plus 4 times x plus 5. So now, that's our first step. Now our second step is to find the LCD. And the LCD for any fractional equation like this is always going to be to take each term from every denominator, but don't repeat. So what do I mean by don't repeat? Well, a real simple thing to point out here would be that if you look in this denominator, I have an x plus 5. And in this denominator, I also have an x plus 5. We're only going to list x plus 5 one time in our LCD. So our LCD is going to be x plus 5 listed once, then x minus 5, x plus 4. That is our LCD. So ask yourself, what do I have to do to this fraction to get the LCD? I have to multiply the bottom by x plus 4. And if I multiply the bottom by x plus 4, I have to multiply the top by x plus 4. So I'm going to do that, and I'm going to use a different color. I'm going to use green. So I'm going to multiply the bottom by x plus 4 and the top by x plus 4. And I do that because x plus 4 over x plus 4 is 1, which means I'm not changing the problem. I'm just making it look different. Over here I've got x plus 4, I've got x plus 5. What am I missing? I'm missing x minus 5. And I'm going to multiply the top and the bottom by that. Okay? So now what does all of this become? Well, let's go down here and take a look. And what do I end up with? Well, I end up with x minus 3 times x plus 4 over x plus 5, x minus 5, x plus 4 minus x plus 2 times x minus 5 over x plus 5, x minus 5, x plus 4. Okay? Now, what do you notice? We have the same denominator. When you have the same denominator with two fractions, what does that mean? That means you can combine these two fractions. You can actually do the subtraction. But before I do that, I need to multiply these out. So what do I get? I get x squared plus x minus 12 minus x squared minus 3x minus 10, and both of these are over the LCD. Okay? Now, big trick here. When you have subtraction, that subtraction sign has to be distributed to each and every term in this second polynomial. And again, I'm going to show this in a different color. So this negative sign is going to be distributed to each of these. And we're going to combine like terms. Okay? So, what is x squared minus x squared? 0. What is x minus negative 3x? Well, minus negative 3x is the same as plus. So x plus 3x is 4x. And then negative 12 minus negative 10. Well, that's the same as negative 12 plus 10, which is minus 2, all over the LCD. and you're almost ready to write your answer, you just need to do one last thing. And that one last thing is to simplify the numerator if at all possible. And when I look at the numerator, I immediately see that I can factor out a 2. So I'm going to factor out that 2, and I'm left with 2x minus 1. And that's going to be over. Now, what is my LCD? I need to write that out in my final answer. My LCD was x plus 5, x minus 5, x plus 4. And then, of course, if this would cancel with anything in the denominator, we would do that cancellation. In this particular problem, that doesn't happen, and so that's our answer. That's our simplified rational expression. If you have any questions, please come see me.